What I want to talk about today, we've been talking about Euler Paths and Euler Circuits lately. So far we have discussed when they exist, how you know if they exist or not, and it's very easy to tell. A Euler circuit exists when, anybody remember the rule for this? Weren't you doing this all weekend?
Not using any of the same letters twice.
Yes. Okay, that's the definition of an Euler circuit. You can make a circuit that is starting and ending at the same point where you cover every edge but you don't repeat any. How do you know it exists?
There's like two or less odd edges.
Yeah, so I think you're remembering the other one. An Euler circuit, which is when it starts and ends at the same point, it exists when, all vertices have even degree. And an Euler path, that's when it starts and ends at different points. That exists when there's only two odds and everything else is even. So this exists when all vertices have even degree except for two of them. Except for two odds, right? And if there are more than two odds, then you can't do anything like Euler circuit or Euler path. All right? This is what we talked about last time. So the question of how do you tell if it exists or not is very easy. You look at all the degrees and you just see which ones are even versus odd. There is a more complicated question, which is how do you actually draw an Euler circuit or Euler path? If you already know that it exists, how do you actually find it? So that's what we're going to talk about today, is finding or drawing Euler circuits and Euler paths. All right, how do you actually, it's easy to tell if it exists or not, but how do you actually draw it given that you know that it's going to exist? All right. Actually, we're going to talk about a procedure for doing this. The fancy word in mathematics for a procedure, an algorithm. People use this in math and computer science to mean just sort of a specific procedure, a description of specific steps which you can use to solve a problem. This is also, the word algorithm is also used to describe like a computer program. Usually when people say algorithm in the real world, they're talking about computer programs, but that's what a computer is. A computer program is a specific series of steps which are followed in order to solve a particular problem. A little trivia here, historical trivia. Anybody happen to know where the word algorithm comes from? This is interesting in my opinion. Algorithm is actually a person's name. This is named after a guy named Al-Khwarizmi, who was one of the greatest of the old Arabic school of mathematics. He lived in what we now call Baghdad at a time when, this is like in the year around like 800, I believe, when Baghdad was like the place to be in terms of science, mathematics and science in the real world. Al-Khwarizmi, his name eventually was translated into English and became that word algorithm. He also invented the word algebra, is named after Al-Khwarizmi. Here's another thing that Al-Khwarizmi invented. You will be amazed. Check this out. This is like how much of an OG this guy was. I'm convinced that everybody here would have known Al-Khwarizmi's name if we were not all taught by the whites. At least I was. Al-Khwarizmi invented this. You know how to do like 729 plus 346? You go like that, like that, like that, right? He invented that. Can you believe it? Actually, it's not entirely clear who exactly invented this, but Al-Khwarizmi was one of the first people to actually write about it in a book. I don't know, most people that I talk to don't even think that that was invented, like human beings were created with this knowledge on this this great Earth. It's not true. Somebody had to come up with that, and it was Al-Khwarizmi, or somebody at least close to him. Anyway, we want an algorithm, a procedure for finding Euler circuits if you already know that they exist. So the idea of this algorithm, so the basic concept, it's not a complicated idea, although it can, you have to try it a few times to sort of get it to stick in your mind. The basic concept is to avoid bridges. Avoid bridges, all right? And where, what I mean by bridge in a graph, I'm going to make a cute little graph here. This is a graph here. Certain of these edges are called bridges. A bridge is a graph where, an edge. A bridge is an edge where if you were to remove that edge, the graph would become disconnected. So this whole thing is connected right now. It's all like in one piece. But there are certain edges where if you were to take them out, the thing becomes disconnected. So an edge is called a bridge. Is a bridge when its removal would disconnect the graph. Removal would disconnect the graph. All right. And on that graph right there, I can see two edges which have that property. If you were to remove that edge, it would make the graph disconnected. I see this one and this one, right? Those are both bridges in this graph. And I actually mentioned this last time, or maybe a couple times ago. An Euler circuit is never allowed to cross a bridge because the Euler circuit has to cover every edge one time. But if you want to say start here, cover everything, and end up back here, you are not allowed to ever cross these bridges. And that's why, I mean, in this graph, it's not even possible to do it at all. But the basic idea for this algorithm is to avoid bridges, because when you go across a bridge in an Euler circuit, there's not going to be any way to get back to where you started from without repeating that edge. All right? These two edges here are bridges. And here's the basic idea. I mean, the basic concept is to avoid bridges. More specifically, I'm going to tell you how to do it. There's actually a name for this particular algorithm. It's named after a person. It's called Fleury's algorithm. Reminds me of that French girl in Harry Potter. Fleury's algorithm is named after somebody named Fleury, I guess. This is the procedure for finding an Euler circuit. The idea is you can basically do whatever you want, whatever works. You know, choose edges as you go. Choose any edges that you like. There's just a restriction. You never choose an edge which is a bridge among all the edges that you didn't use yet. So I'm going to try and do that. Choose any edges that you want, but never cross a bridge among the unused edges. This sounds very simple when I say it like that, and it's not that hard, but you'll see it does get a little complicated, and you have to sort of train your mind to look at the graph properly while you're doing this. Anyway, that's the idea. You just choose whatever edges you want, and it's going to work out as long as you never cross a bridge among the unused edges. So what I mean by that, here's an example. This is a sample graph. All right, let's say this is my graph, and I would like to find an Euler circuit. Let's find an Euler circuit. All right. First of all, you should just make sure that there really is an Euler circuit. Remember to determine if there is or not, you look at all of the degrees and make sure that they should all be even, right? That's a 2, that's a 4, that's a 2, a 4, and a 4. So they're all even. That means there really is an Euler circuit. And it also means that I don't have a specific starting point. You can start wherever you want. In an Euler path, remember, you have to start at one of the odds and finish at the other odd. But in an Euler circuit, it doesn't matter where we start. Let's start down in the lower right, just for fun. Let's start right there. Just because I said so. You don't actually have to start there, but just because I'm doing this example, this is my class, let's start here. All right, and we have to finish there also. All right. I'm going to try to kind of do it very step by step. Now, once you get good at this, you can just basically do the whole thing in your head, but I'm trying to explain the process here. So I'm going to try and narrate my little steps here. I'm going to begin by doing this edge. Now, you could have gone straight up, or you could have gone up and to the left. It doesn't really matter. And maybe I'll just label this with a little 1. That was like step 1 in my choice of the edges to choose. And now, after going across that edge, so after step 1, look at the unused edges. Now, if you know what to look for, basically I'm looking at this graph, but ignoring that one that I made red. So everything else is going to look like this, right? Those are all the unused edges, and now I'm right here. And the rule is you can choose whatever edge you want, but never use a bridge among the unused edges. So you look at this graph over here, or equivalently, you look over here, you just ignore this one that you already used. And from here, I can choose any edge I want as long as it's not a bridge. Now, I have 3 choices, and actually none of them are bridges in this graph right now. So I can go any way that I like from here, just for the sake of doing it the way that I did it on the paper, I decided to go to the right. So I go up here and then across this one. All right? That's my second choice. What does it look like now after step 2? Now, the edges which remain look like this, right? So after every choice you're making, sorry, I'm off the bottom. Now I'm off the top. Off the heezy. Now, every time you make a new choice, you look at the edges which remain, and you make sure you do not cross a bridge among the edges which remain. All right, so like I'm sort of at the red dot now, and I have to choose. Again, there are no bridges that I need to worry about staying away from at this point, and so I can choose any direction. Although, actually, you don't want to go down here because then you would finish the circuit without having covered everything. So that's another thing. You don't want to finish too early. So I could either go straight up or up and to the left. Maybe I'll go up and to the left, like so. That's my next step. I'll call that step 3. So after step 3, now is the first step where actually I would say something interesting happens. I'm up here in the corner, and the edges which remain to be used look like that. All right, and at this point, actually, because I've been taking away so many edges, there are many bridges at this point. I would say that edge right there is a bridge. Also, this edge is a bridge, right? Among the edges which I have not used yet, there are 2 bridges in this case. There's also a dot there, right? So for my next choice, I am not going to choose that one to the right, but I could choose either, this one or that one, right? And how about I just go straight down here? So I'm going to come down this way. These numbers are confusing me. I'll say that was choice number 4, right? After choice number 4, sorry, I'm going to have to scroll at this point. After choice number 4, the graph now looks like this, right? And I'm right there. And now actually I think it's clear from here where you're going to go next. Well, you just got to go around and cover everything that's left, right? Now there are no more choices ever. I only have one choice to do from there. So on my original picture, it looks like down here and back up this one, across the top, and down the side. And that's it. All right? Got symptoms.
Allergies.
Yeah, I feel that. All right, this is how we do it. So the all of this, which took me a few minutes to explain, really you can in most cases do it all in your head. I'm just trying to be very specific about what you're supposed to be looking for. As you draw this line, you are trying to look at all of the edges which you didn't use yet, and make sure that you never cross any bridges among the unused edges. All right? Anybody got any questions about that? I got a lot more examples that we're going to try, but this is the basic idea. All right, let's try some more examples. So I'm going to try and write in words what the actual procedure here is. So this is Fleury's algorithm. So for Euler circuits, I should say, you do it slightly differently for paths, but we'll talk about that. For Euler circuits, those are the ones where it starts and ends at the same point. You can start wherever you like. Start anywhere. And as you go, you can choose any edges, except what I said before is don't choose a bridge among the unused edges. And also there was another rule which I had to abide by once, was just don't finish early. All right, we had, in the example that I just did, there was one point at which I could have gone back down to the starting point, but then I would have got stuck there before having covered the rest of it. So this is a simple kind of second rule there. All right, don't finish too soon is the other one. Okay, that's really the whole procedure. Let's just try some examples. I got a few, and then I got some for you. How about this? Like that. Find an Euler circuit in there. Find an Euler circuit. All right. You might want to verify that all the degrees are even, but they are in this case. The ones on the outer corners are 2s, and then I think everything else is a 4. So they are all even degrees in this case. And let's say I'll start in the upper left corner. It doesn't matter where you start. If it's going to be a circuit, you'll end up at the same point anyway. All right, let's just do it. So I'm going to go over to the right first, maybe. After every choice you make, you have to look at all the edges which are left. So when I'm looking at this picture, I'm trying to sort of filter out that red one that I just chose and look only at the black ones which remain. And I have to make sure I never cross a bridge among the black ones. Although at this point, I don't see any bridges among the black edges which remain. You have to kind of look carefully to do this properly. I don't see any bridges there, so I'm going to just do whatever I like. Maybe I'll go down to the middle. I don't know. You can do anything you want as long as you are not ever crossing a bridge, and then everything will kind of magically work out. Again, I am trying to hold in my mind just the black edges which remain, and I don't think there are any bridges at that point. It would look like, just the black edges which remain. At this point, looks like this. This is the picture you should be looking at. I believe those are all the edges which remain, and there's no bridge in there. So I don't have to worry about crossing any bridge at this point. Maybe I will go to the right here. All right. Now, the picture that I'm looking at in my mind now looks something like that. Okay. Still, I don't see any bridges over there, so maybe I will go, I'll go up, I guess. And then once I go up, I suppose I have to go to the left now that I'm up there. All right. At this point, maybe just to take stock of where we're at, I'm looking at this for the rest of the graph, which is not yet used, right? And still, I don't see any bridges in there. You've got to make sure that the rest of the graph is sort of staying all together, all right? Is everything all right? I see a lot of people like laughing to themselves. Am I doing something funny? Maybe you're all just laughing for different reasons. I don't know. It's a little weird. I don't want to steal your joy. It's okay if I say something that I think is funny and everybody laughs. That's okay. I start to wonder otherwise. Yeah, let's continue. I don't know what they're all laughing about. Let's continue. I'm right here at this point, right? So you got to go down that diagonal. That's the only edge to choose at this point. And then I'm looking at something like this, right? And from there, I don't want to follow any bridges. I also don't want to start, I don't want to finish early. So from here, you should not go up to the starting point again because I'm not done yet, right? You can either go straight down or straight across. Maybe I'll go down here. And after that, I have to go over to the right. All right, at this point, I should be thinking about this picture here. Now, actually, there is sort of an important choice to make. This graph here, the parts which is left over, now has several bridges. This is now a bridge, and that's a bridge. So I should not choose those edges. I should choose either the diagonal one or the one going straight across the bottom. And it doesn't matter which one. I'll choose the diagonal one, say. The diagonal one makes me go up like this. All right. Now the picture of the ones which are left is just like a big line. And so I just follow all those lines and I'll be done. So to finish, I go down here, across here, up the middle, over there, and up there. There we go. All right. That's how we do it. Once you get good at this, you can do it much faster than I did. I was trying to explain every little thing, but this is Fleury's algorithm. Anybody got any questions about that? All right, let's just try one more, and then I want to talk about Euler Paths. Everything that I've said so far is just about Euler circuits. How about this one here? Maybe I'll let you guys try this one. I have another one for you all to try after this, but how about this one? Find an Euler circuit here. Start wherever you like, and don't use any bridges. I got another one for you to try too. In each one, see if you can find an Euler circuit using this method. Sorry. Come around and see how you're doing. And make sure your circuit is legible after the fact. Doing okay? There's usually one on the bottom. It might be impossible. All right, let's chat about these. So the top one here, this can be a little tricky maybe, although oftentimes if the graph is small enough, you can just sort of choose edges at random and hope that it works. I don't know if that's how some of you were doing this. If it's small enough, that will often work out. But anyway, I will start up here, and from the get-go, there are no bridges here, so I can choose whatever I like. Maybe I'll go down this one first. Probably none of you are going to make my exact same choices. After choosing that edge, I'm looking just at the black ones which are left, which would be like this. Those are the ones which are left after I chose that first edge. There's still no bridges in here, so I can choose any one of them. Maybe I'll go up to the middle, and then I have to continue up to the top. Now, I know I said you shouldn't finish early, although in this case, I'm not necessarily done. You just don't want to get stuck at the starting point, but at this point, I'm not going to be stuck because there are more edges here. I'll come down maybe this one here. At this point, the edges which remain at this stage are this, this, and this, right? I think those are all of the edges that are left. I should not choose this curvy one back because then I'll be stuck at the starting point, but I can choose either this straight one or this curvy one down there. Maybe I'll do the straight one, and then this curvy one, and then all the way back to the beginning. All right, that's how I did it. There are many other ways that you could have done this one, but that's how I did it. Please make sure that the thing that you draw should be readable, legible after the fact, all right? I'm trying to draw mine in a legible way. One way to help make it legible is as you're drawing the curve, it probably should not go right through the vertices when you're drawing it. Make it miss the vertex a little bit so that I can tell if you're sort of turning to the right or turning to the left or whatever. All right, let's try this other one. This one, again, you can start wherever you like. I'll start in the corner here and then follow edges however you like, but don't use a bridge among the unused edges. So this one's pretty big. I think I should be able to just kind of do whatever for a while, making sure that what remains is all staying in one big piece. I'm just going to go around the edge, maybe the outer edge first. I'll use this lumpy one. All right. At this point, I get a little concerned. I don't want to go back here because then I'll be stuck at the starting point. So I suppose I better go down the diagonal, or I could go straight down. Maybe I'll go down the diagonal. All right. Remember, all this time as I'm drawing those edges, I am trying to hold in my mind what does it look like the ones that I didn't use yet. So in this case, the ones that I didn't use yet looks like. What's happened? I think I did something wrong. Nope, I didn't. Sorry. I need to work on my self-confidence. What remains here looks like this now. I think that's what it looks like now. And I am now right here, right? There are some bridges, like right now this is a bridge, so I should not use that edge until I have to towards the end. So I'm going to go around here. Don't go straight up because that's a bridge at this point, but I'm going to go maybe down here, across here, up there, across, down here, around this little guy. All right, now what remains at this point is I just used up these ones. Right? Now I'm looking at that for the edges which are left. And those all just go in a single path, so I just go across all those edges which are left. And that's what it looks like up here and over there. All right? That's how I did it. It's unlikely that you made all the same choices as I did, but I think that's working out. Any thoughts about that one? All right. We got a little bit of time left. I want to talk about Euler paths. All of this has been about Euler circuits. How do you find an Euler path? Remember, an Euler path is when it doesn't start and end at the same point. So what about Euler paths? The answer is actually you just do the same thing, and it also works for Euler paths. What about Euler paths? Well, I'll say you do the same thing, the same process. The only difference is you have to start at one of the odds and end up at the other odd, right? So do the same process, but start at an odd vertex. Now, it is a fact that you're going to have to end at the other odd vertex, but you don't actually have to try to do that. If you're doing the algorithm properly, you will just automatically, magically end up at the other odd vertex. So start at an odd, I'll say odd degree vertex, and you will auto-magically end at the other odd. If you do everything right, you will automatically end up at the other odd degree vertex. You don't even have to try. All right, let's try one like that, and then I got one for you all. How about this? So this one has an Euler path. Let's try to draw it. Draw an Euler path. All right. you have to start at one of the odds and end up at the other odds. So maybe we should start by just deciding what are all the degrees so that I know where to start and finish. The degrees here go 2, that's a 3, that's a 2, that's a 4, a 2, a 4, a 4 in the middle, a 3, and a 2. All right, so you have 2 3s in this case. One of those has to be your starting point. The other one has to be your ending point. It will automatically be your ending point. Maybe I will begin with the 3 on top and see what happens. All right? Starting with the 3 on top, we do the same old thing. You choose whatever edge you like. It's just every time you make sure I'm not going to choose an edge which is a bridge among the ones that I didn't use yet. So I will go over here maybe, down here. I think I can just continue without worrying. So at this point, maybe just to take stock of what's going on here, the edges which remain at this point are like that, right? Those are all the edges that are left. And there are no bridges in there, so I can just continue choosing whatever I like. Maybe I'll do the diagonal one first. I like to kind of cover, I think of this in terms of like the zones. I like to I covered everything now on the right side. That's the right-hand zone. This is not a technical concept, but I like to try and maybe start on one side and cover everything and move my way over to the other side. That sometimes works. Just make sure you are not covering any bridges in what remains, right? Having covered all of this stuff here, what remains is now like that much. And there's still no bridges in there, so I can do whatever I like. Maybe I'll go down one. From here I have to go to the left. And now what's left is that. And I can still continue however I like. I'll go up this time. And then I'm looking at a square, and I'll just go around what remains. Here to here to here to here. And look at that, I ended up at the other 3, all right? Automatically. That's just what happens. All right, it's the same procedure. Just make sure you start at one of the odds, and you will end up at one of the other odds. All right, I got one more big one for you all to try. And then we can talk about something completely different. How about this one? I have a big square like that with another square inside it. And another square inside it. How about that? Try this one. Your job is to draw an Euler path. You'll have to look carefully at the degrees first to figure out where you should start and where it's going to finish. I'll let you handle that. Make sure you copy it down right. If you miss an edge, then it may very well be impossible. Your first job should be to decide where you're going to start. Looks like some people are doing all right. Let's chat about it. You should start by deciding where I'm gonna start and finish. And to do that, you have to find where the two odd vertices are. And in this one, they are these two. They each have degree 3, and all the other ones are evens. They're either 2, 4, or that one. This one here is a 6. But anyway, I'm going to start at one or the other of those. Maybe I'll start at the upper one. And then I have to go across every edge without duplicating edges. And I got to cover all of them. So we think of it still in terms of bridges, right? Maybe I'll come down here and up there, down like that. Right? I did that much. Looking at the edges which are left, the black edges which remain, I still don't see any bridges. What I see is those two plus that one, and then all these ones out here. So I'm going to go down this diagonal to get to the kind of the outer regions here. And then I want to go around, maybe I'll go like around the very big square, all the way around, and then all the way around the slightly smaller square, sort of in the middle. So do it like this, around here, all the way around the outside. And then I'll go around the sort of other square in the middle. You could also have gone around like each individual triangle if you wanted to. I didn't want to, but you could have. All right. Now I've covered everything sort of on the outside, on the outskirts, if you will. I think there's only a few more edges left to do. I have this one, and then I think there's only 2 more edges, right? Here and here. And I'm going to end up back at the other odd vertex, which is what we want. Up here, and then down across the middle like that, finishing right there. All right. I think I did it. If you did it, you probably did it a different way than I did. There are many possible answers here, but that's one way to do it. All right, and it looks like our time is about up. So tomorrow we will do all review for the test. Let me know if you have homework questions.